The moon is Earth's closest neighbor in space. It is a fascinating world, illuminated by the sun. The moon travels around our planet in a path we call an orbit. This celestial dance takes about a month to complete. As the moon orbits Earth, its appearance changes. These changes are called phases. We see the moon because sunlight reflects off its surface. The amount of reflected sunlight we see depends on the moon's position relative to the sun and Earth. When the moon is between the sun and Earth, its illuminated side faces away from us. This is called a new moon. We cannot see the new moon because its dark side faces us. As the moon continues its journey, we begin to see a sliver of light. This is the waxing crescent moon. Over the next week, the illuminated portion grows larger each night. This is the first quarter moon, followed by the waxing gibbous moon. Finally, when the moon is on the opposite side of Earth from the sun, we see a full moon. The entire face of the moon seems to glow. Then, the illuminated portion gradually decreases, passing through the waning gibbous last quarter and waning crescent phases until it becomes a new moon again. The moon's journey across the sky is a captivating sight. It rises in the east and sets in the west, just like the sun. However, the moon's position relative to the stars changes each night. This is because the moon is constantly moving in its orbit around Earth. As Earth orbits the sun, our perspective of the moon changes. Think of it like this. Imagine yourself standing in the center of a carousel. As the carousel spins, your view of the objects around you constantly shifts. Similarly, as Earth travels around the sun, our view of the moon changes against the backdrop of stars. Each night, the moon rises about 50 minutes later than the previous night. This is why we sometimes see the moon in the daytime sky. When the moon is in a certain phase, like a crescent moon, it can be visible in the early evening sky. This is because it has risen later than the sun and is still visible before it sets. The moon's changing position also affects its visibility. Sometimes the moon appears high in the sky, while other times it seems closer to the horizon. This is due to the angle at which the moon's orbit intersects with Earth's horizon. The moon's journey around Earth sometimes leads to spectacular events, eclipses. An eclipse occurs when one celestial body casts its shadow on another. There are two types of eclipses we see from Earth: lunar eclipses and solar eclipses. A lunar eclipse occurs when Earth passes directly between the sun and the moon. Earth's shadow falls on the moon, temporarily dimming or even completely obscuring it. A total lunar eclipse can cast a reddish hue on the moon, as sunlight is filtered through Earth's atmosphere. A solar eclipse happens when the moon passes directly between the sun and Earth. The moon blocks the sun's light, casting a shadow on Earth. During a total solar eclipse, the sky darkens as if it were twilight, and the sun's corona, or outer atmosphere, becomes visible. Eclipses are not monthly occurrences because the moon's orbit around Earth is slightly tilted. This tilt means that the moon, Earth, and sun don't always align perfectly for an eclipse to happen. Instead, eclipses occur in cycles, with specific alignments happening only occasionally. As the moon orbits Earth, it doesn't always seem perfectly still. Instead, it appears to wobble slightly. This wobbling motion is called libration. Libration is caused by a combination of factors related to the moon's orbit and rotation. One type of libration is called longitudinal libration. This occurs because the moon's orbit around Earth is not perfectly circular but slightly elliptical. As the moon travels along this oval-shaped path, its speed varies. This variation in speed, combined with the moon's rotation, causes it to appear to rock back and forth slightly. Another type of libration is called latitudinal libration. This occurs because the moon's axis of rotation is tilted slightly with respect to its orbital plane. As the moon orbits Earth, this tilt allows us to see a little beyond the moon's north and south poles at different times. Libration might seem like a subtle effect, but it has significant implications for our understanding of the moon. Because of libration, we can actually see more than half of the moon's surface over time. This has allowed astronomers to create detailed maps and study a greater portion of our celestial neighbor. Don't forget to like, subscribe, and hit the bell icon to stay updated with more celestial journeys.